Good morning, everyone. I am the last thing standing between you and lunch, so let's immediately dive into the content because we have a lot to cover today. My name is Glenn. I'm CTO at Azure Belgium. I'm also Microsoft Azure MVP and an Azure advisor. Next to that, I'm a Microsoft certified trainer. I'm an architect and I've been involved in several IoT and cloud projects across Belgium. I've been doing Azure since around 2014. It's the first time I'm able to present for the community here, so I'm very delighted to be able to present here. Unfortunately, due to the time, it is only virtual, but I will be happy to join you once this pandemic is over. Some quick facts about Azure. Azure is focused on Azure as a platform, and we have been focused on Azure since 2011. We have around 60 employees. Most of them are technical people, 4 MVPs, and we currently have 2 offices, one in Helsinki and one in Ghent. We also have a lot of cool logos from Microsoft, and maybe the one most important is that last year we were Partner of the Year finalists in application innovation. With that said, let's immediately dive into the content. And let's talk a bit on IoT. There has been a couple of IoT sessions yesterday, and I believe there's another one later today. So be sure to check out the great content that is available for you. So IoT is all about things, getting those things connected and creating insights and actions upon to that. But before you start any IoT project or start creating an IoT solution for your company, it's important to make one of the most important decisions that there is. So will you choose for a platform as a service setup, or will you choose more the software as a service setup? The biggest advantage of platform as a service comes, of course, with the biggest challenges. The fact that you are in full control of the feature set, scalability, and so on. Again, an important thing is that do not treat IoT just as a simple IT project. Make sure that you integrate IoT strategically in your company, because that will bring you quite a lot of benefits in the long run. Just think about on how mature is your IoT organization to cope with those IoT projects. So before we dive into the details of Azure Digital Twins, I wanted to give you a quick recap on what the Microsoft's IoT product portfolio is looking like. So first of all, there's the Azure IoT solutions. You can see those more as the software as a service offerings from Microsoft. You have the connected field services from Dynamics. You have the IoT accelerators. You can see those a bit as, let us say, reference implementations. And then there's, of course, IoT Central. IoT Central is the go-to software as a service offering for IoT. And you can see it a bit, with all respect said, as the Office 365 for IoT. It's easy to get started, and you get your solution up and running in a matter of hours. Then there's the Azure IoT services, where you have Azure IoT Hub, Stream Analytics, Cosmos DB, and so on. You can see those as the platform as a service offerings of Microsoft. So the building blocks that Microsoft provide for you, and allowing you to build your own custom platform as a service IoT offering. So important set of services. And of course, over the last couple of years, we've seen a dramatic increase of IoT solutions that require edge support. And of course, Microsoft has been heavily investing in those, where you have Azure IoT Edge, you have the IoT Device SDK, and you have a lot of those Azure services being deployed or being made available on the edge. Next to more the services level, you have also the offerings of Microsoft more on the device side of things, where you have Azure Sphere that is offering microcontrollers, Windows IoT that's offering an operating system for IoT devices, and of course, as already mentioned, those edge devices that allow for cross-platform and open source, and give you, for example, offerings like Databox Edge, Azure Stack Edge, and so on. With that said, we're moving from connected assets offering, where you have your classic things, insight, and actions approach. We're seeing that is starting to evolve. So there's a new trend emerging, and customers want to model their physical environment first, and then keep that model up to date with IoT data. It's a more natural approach for IoT solutions than just those things, insight, and actions. So, and we're seeing that the next generation of IoT solutions will model those relationships between people, places, and devices. So we're seeing today, we're still in a connected assets world where there's still a heavy focus on those things, insight, and actions. But as connected solutions starts to evolve, we're emerging more and more to a connected environment where IoT is really a leverage for people, spaces, and environments to allow you to create that rich experiences for people driven by IoT data. And then as we move more and more towards the future, we're seeing that these environments are really starting to be interconnected and will start creating really connected ecosystem. Again, leveraging and optimizing the experience for people that live, work, or do things within those environments. And this is really where digital twins comes into play. So digital twins is there for creating the next gen of IoT solutions. So it has a open modeling language. It has a live execution environment. You can input from IoT and business systems, and you can extract your output to time series insight, storage, or analytics. So what digital twins enables is really merging data from IoT systems and business systems into one connected environment. So as you might know, Digital Twins is now at its second version. The difference between version 1 and version 2 are quite significant. For the people that worked with version 1, version 2 is an update based on the feedback that has been provided to the team from the first version. So a couple of things that has been changed for the better is that modeling is now based on open standards. I will come back to that later. There's a more flexible topology definition. In version 1, you could only do JavaScript, while now you have external compute. You can bring your own compute as you want. IoT Hub is no longer built into the service, but you can bring your own IoT Hub. It has improved scaling compared with version 1, where version 1 was really limited regarding scales. So let's take a look and let's see about the details we have for digital twins. So let's start first of all with the open modeling language. So digital twins allows you to create custom domain models using what is called the digital twin definition language, so DTDL. So it's quite a mouthful. So it's based on JSON LD, and it's used in other services like IoT plug and play, time series insight data modeling, and so on. So you can see here that the digital twin definition language is completely aligned with those other IoT services that are provided to you by Azure. So it's really there to create that integrated environment. So models can define a couple of terms. So you can describe your digital twin via a set of things. First of all, there's the properties. Properties, you can see that as a data field. They have state on the twin and have backing storage. Those can be read at any time and are available for you to read. Then there's telemetry. Telemetry, basically explaining as it is the measurements of events, sensor readings, events that are happening, and so on. An important difference between properties and telemetry is that telemetry is not being stored on the twin itself. It's a stream of data, it's a series of data, and has a limited time to live on your twin. So that's important to take into account. Then you have components, and components allow you to build model interfaces as part of the twin. For example, if you are modeling out your mobile phone or your cell phone, you could define a model for a camera and then use that component as front or back camera. You can see this if you're used to doing programming. You can see this a bit as defining a set of interfaces. And then the most important thing is probably the relationships. So relationships allow you to define how to interact with other twins and what is the relationship of those components. It is there to allow you to create to connect your twins into a knowledgeable graph, and allows you to specify how twins are interconnected or how twins are linked to each other. With that said, let's take a look on how that modeling language looks like. As an example, what I did is I modeled out my house as a reference, and if we take a look, here. This is what is called the top level of my graph. Here I've modeled out my house. So important here is that the type. Let me zoom in a bit, that this is more visible for you. Important here is that the type of this must always be interface. It is something that is there, that's required by digital twins, so that one must always be interface. And then an important one is here the ID. Your ID has to start with DTMI, so digital twins modeling interface, And then you can specify your domain, your identifier. In our case, this is just a house. And then after that, you can specify a version number. What you can do then is give that interface a more proper name. In this case, we just said this is our house interface model. And then here that context is a fixed value for digital twins. All remaining interface data is then added into a contents array. And there you can describe really the details of your digital twins. In our case, what we defined is two properties. One, a construction year, so the year my house was built, and the owner of the house. Remember, properties are data fields and are stored on the twin. And when you initialize the twin, those are required for you to bring up. The next thing I've created is a type, as you can see, a type relationship. I gave that relationship a name, and that's, as you can see here, that relationship is targeting it's targeting a specific ID. In our case, this is targeting the ID that we have used to define our floors. Let's take a look at that one. So here, as you can see here, the ID is demo floor 1, and we are using that inside our house here as a target for that relationship. Nothing very specific on this model. So we have the ID, we have a proper name, the two fixed values of digital twins, but what we define here is another relationship. So my house has several floors, and on those floors there are rooms. So let's take a look at those rooms. As you can see here, again, the ID, we have what I defined here is two properties, and those properties will be filled in by the telemetry data that is coming from the sensors. So I will use eventing to update those properties as we go. So our room has sensors, and those come from the sensors that we are targeting here. So, and as you can see here, we have a sensor. That sensor has a specific firmware version of property, and it has telemetry that is containing temperature and humidity. And that's all needed basically to define our twin. So now we have our models ready. Let's jump back to the slide. It's time to talk a bit on the live execution environment. So the live execution environment allows you to create twin instances of your model. As already mentioned, twin instances and relationship, basically they create a graph of your environment. You can then visualize that via the Azure Digital Twin Explorer. I will come back to that later. And you can use the eventing system to drive business logic and data processing via external compute, such as Azure Functions. You can extract insights from the environment with the Query API, and you can input data from IoT Hub and other data resources. So important to mention here, this live execution environment is nothing more than a set of APIs. So what you're doing basically is talking to a set of APIs. If you create a twin, you talk to the APIs. If you query data, you will talk to the API. If you show the graph that is available, you are talking just to the API. So important to mention, what you're getting is a set of APIs. As already mentioned, you can use digital twins to route data to event hubs, to event grid, or to service bus. And having those routes and endpoints allows you to have different scenarios. You can store your data in Azure Data Lake. You can connect your data to logic apps. You can connect to time series insight for historical series and so on. So it is important to keep that in mind. So enough talking from my side. I wanted to show you a end-to-end demo of digital twins, so you can completely understand how this is working. So let me try to explain the demo. So first of all, here what you see is you see the JSON file, so the model files that we had during the previous demo. What we have done, or what I already did, was upload this model to my Azure Digital Twin environment. So these models are now being made available over there. So I have those models available. And once I have those models available, I can start the interaction with the digital twin environment and start creating twins. I will show you how that works later during the demo. So I will create twins, I will set up the relationships, and so on. So once we have set up that, what we will do is we will, with a set of simulated devices that are connected to IoT Hub, we will via external compute, called the Digital Twins APIs, and keep the model or update the model with the IoT data that we're receiving. I will show you how the data is flowing through the system. And once that is done, I will then show you how you can connect external systems, in our case, time series insight, to Azure Digital Twins and so on. So this is the end-to-end demo that has been set up. So let's jump immediately in there. So as you can see here, let me just run this query. As you can see here, this is the Azure Digital Twin Explorer. And I've already uploaded my different models towards that service. If you would look in the Azure portal how that looks like, let's jump here to the Azure Digital Twins. So this is how the service looks like when you create it, when you create the service. So what it basically provides you is with a service. You have a host name, and that host name is the endpoint for the APIs for you to use. So that allows you to interact with the digital twins. So now that we have our models uploaded to the digital twin, we can now start to create twins based on those models. Let's take a look on how that works. So let me open Visual Studio and let me walk you through the code. So the most important point of interaction here is the digital twin client. The digital twin client is a NuGet SDK offering from Microsoft, allowing you to interact with the digital twin environment. So in our case, as already mentioned, we would like to create our top level, basically our house. Let me quickly walk you through the code on how that works. So first of all, if you want to interact with the Digital Twin client, just for your info here, I have instantiated the Digital Twin client, and I'm assigning this client to a top level client, and I will communicate throughout this code with this Digital Twin client. This is just the SDK provided by Microsoft. So how does this work? If we want to create a digital twin based on a model, we need to provide, first of all, an array of metadata. So we need to give the model. Remember, this was the ID of the model, and the kind is digital twin. We then take this metadata and create a new JSON dictionary with that metadata and the properties defined on the digital twin. So remember, here our house digital twin had construction year and owner. So we need to provide that as an input to our twin data. Then we use the create digital twin async, and what that expects from us is you need to provide a digital twin ID. In our case, I'm just as a part of a small joke, I gave that a local host IP as an ID, and then we need to provide the digital twin string as a JSON file. So in that way, this dictionary is being serialized as JSON, and we can create digital twin. So if we scroll further, we can do the same thing with the floors. So we create the metadata of the floor, we add it to the twin data. The only difference here is that we can create those three different floors in one go, because the metadata and the data of the twin is the same. What is only different is the ID. So if you would take a look at the code here, you create the digital twin async, you create three different floors with the same metadata, but with different IDs. So now we have defined floor, we have a house with 3 floors. And then basically the same for the rooms. So the metadata, the twin data is the same, and then we create the batch of floors that are available. Same thing for the sensors. We add the metadata and create all the sensors that are available. So the next thing that is quite interesting is to show you on how we can create a relationship. And this is the code to create the relationship. Again, it's a bit of the same methodology. You need to specify a JSON string. So you need to have a target ID. Your target ID, remember, is the ID of the digital twin that we've created here. So floor 1, that is our target ID. Relationship name floors. Be aware, this floors needs to match the name that is within the relationship here. Let me do it here. And then you define, you say create relationship async. So what we're saying here, our digital twin ID, with this ID, we want to create a relationship that is called, that has ID localhost to floor 1 with the JSON relationship. So we're serializing this data here. So target ID and the relationship name as part of the JSON file here. So we do create relationship with this ID to floor 1. Same thing for the rooms. So we have floor 1 as a parent ID, and we create a target ID kitchen. And this is basically how we create the twins throughout the entire ID. For people who want to take a peek at this code is available on GitHub on my account, and be sure to take a look at that one. So let me save that, and what we will do is let me go back to the Digital Twin Explorer. Excuse me. So as you can see here, if I run the query, there is nothing available now. So what I will do is I will go back to the code. I will start this up, and I will trigger the code to run. So basically what I'm now going to do is I will execute the set of create twins and create relationships, so that these twins and these relationships are being created in my Azure Digital Twins environment. So let me do setup digital twin. So of course, I need to authenticate first, so authentication is complete. And as you can see here, he's running through all the creations. So if we take a quick look, so the local host twin has been created, the floors have been created, then the rooms have been created, the different sensors, and then all the relationships have been created. So if we do a run query now, if we query the environment, you would see that a visualization of that digital twin is being created. So, and if we would click on those digital twins, you will see that that there's the metadata here. The different floors have also their metadata. The different the sensors have their metadata created and do not have those. Well, the twin is there, but there's no data flowing in. So the question is, how do we keep this model up to date? Well, this is done by leveraging the eventing and messaging of Azure in combination with external compute. So let's take a look on how that works. Let me just quickly go back to the slide and show you where we are in the demo. So we have our models being created, and we interacted with the digital twin to create our twins and set up the different environments. So now we're going to this part of the demo where we will use devices to keep our digital twin up to date with data. So let's take a look on how that works. So let's go back to the Azure portal and take a look here. So first of all, I've created an IoT hub and have some devices made available over there. So you can see here that this is a thermostat. This one is wrong. This one was from another demo that has been used. So to keep that twin up to date, we have to leverage Event Grid. As you can see here, what we did was we have a topic that is using the device telemetry and is outputting everything to Azure Functions. So every time telemetry arrives on IoT Hub, we put a message on the event grid, and that then is processed by Azure Functions. If we go to the to the details. So this is processed by Azure Functions, and what we're doing here is we will just use again the client SDK available from the digital twins to update the twin property. So what we will do is we will know what digital twin is coming in, and we will update this through Azure Functions by calling the API. So if I would go back here, so Azure Functions will do a call into digital twins to update the sensors. So a question that that I'm receiving as a lot is, okay, why is this external compute or this intermediate hub necessary to update digital twins with IoT hub data? Well, as already mentioned, digital twins is a set of APIs, and currently there's no story inside IoT Hub to directly transmit events or data towards digital twins. However, this is quite a common ask, and I would see that that being made available as part of the evolution of the service, as this intermediate processing of action might feel not that natural. So what we will do is I will immediately start my device simulator. So, and as you can see here, this is now sending messages for the different sensors. And if we would go, so these messages are arriving at IoT Hub, and through Azure Event Grid, we are pushing those messages to Azure Functions, and Azure Functions will use the API to update the digital twins. So if we would take a look at here now, we can see here that our digital twin is being updated with temperature and humidity. And you can see here that data is really flowing through the system. So if we would check the update here of temperature of sensor 005, you see that the temperature is 18. If we do another refresh, it is 19. So we are now, by leveraging IoT Hub Event Grid and Event Grid, updating all these sensors with the data that we have here. So this is a great way of updating your digital twin. So now that the data is flowing through the digital twin, the question is how you can, or how do you update or how do you trigger external data processing? Remember, in our solution, once we have the data, we want to update, for example, time series insight to also display those sensor values. Well, this is done by a thing called routes. So if we would go to the digital twin environment, you can see here that there's a thing called a sub-tab to connect your outputs. And if you're familiar with IoT Hub, this is a bit of the same principle. So first of all, you have endpoints. You can create external endpoints. Currently, only Event Grid, Event Hub, and Service Bus is supported. So those are the outputs that are made available. In my case, I've added an Event Grid endpoint and an Event Hub endpoint as a matter of a demo. And then the most important thing is the event routes. So the event routes allow you to show you or to create an event route. And an event route it's really simple. So you create an endpoint that you have created, and then you can filter on certain event types. In our case, what we are interested in is the twin update event. So every time a twin gets updated by either a sensor value or something else, an event will be raised by Azure Digital Twins and will be put on the endpoint that is available here. So in our case, we have here an Event Hub route that is filtering, as already mentioned, on the twin updates. That Event Hub is then connected with a service called Time Series Insights. And if we would go and take a look at that service, you would see here that these values are being transmitted. So what I can do here is I can add the temperature for, let us say, sensor 1, 2, 3. Let me put them on the same. Let me hold on, excuse me. So let me zoom here. So now I am zooming into the different sensor. You can see here that the sensors are arriving towards this value. If you want, you can then explore the raw events, and you can see here that the raw events are arriving as we speak. So this is a very interesting approach on how to leverage external system with Time Series Insight. Again, because there's different routes available, like Event Grid, Event Hub, and so on, we can output the data of our digital twins to much more events. So with that said, we come to the conclusion. So Azure Digital Twins is your platform to build those next generation IoT solution. Remember, IoT is evolving from an asset-driven environment to be more like an environment-driven experience. So it's really building those next generation IoT solutions. So it's built around the ability to model your environment through JSON, and it's really focused on those event-driven approach. Remember, everything you do or interact with the platform is being controlled by using the REST APIs. And important is that we're really talking about a platform as a service approach here. Before we jump into the questions, I would like to thank the conference. I would like to thank the sponsors, and of course all the different communities involved in making this a really great event here. So as already said, thank you for having me. I would love to meet in person next time I speak at this conference. So let's hope things go better really soon. So for people who want to take a peek look at the demo is available on my GitHub page. You can contact me through Twitter or drop me a message on GitHub. With that said, I will keep the line open, and I will answer the remaining questions over the chat. I do not want to go without wishing you a good continuation of the conference. Be sure to check out some of great sessions later this afternoon. And don't forget, there's a couple of awesome workshops tomorrow available for you. So definitely take a look at those ones. So if you do not have any questions, I would say enjoy your lunch break. As already said, I will go through the questions on the chat, and then if there's no questions afterwards, I would like to thank you for attending this session, and I hope that you learned a thing or two about the digital twins. Thank you.